Welcome to the Lighthouse video series, where we go into the technologies that Nichols Portland Inc. offers to the marketplace and how our customers can utilize those technologies to their benefit and also to optimize the technologies to their maximum potential. I'm Stephen Medill. I'm the Executive Vice President of Sales and Marketing for Nichols Portland Inc. Today I have with me Jason Osborne, Vice President of Advanced Engineering, and David Smith, Director of Engineering for our MIM Technology. Today, we come to you from the Center of Excellence located at Alpha Precision Group facility that is in Ridgeway, Pennsylvania. This facility is focused on the MIM technology and additive manufacturing technology. So today's topic is talking about what is the process of MIM and what does that process consist of? So gentlemen, what does the process for MIM consist of?
Every metal injection molding part will go through four main processes, four main core processes. First is compounding, where the actual material is made. Second is injection molding, where the part is actually formed. Debinding is the third process, which is really a prerequisite to sintering, where the first component of the binder system is removed. And then sintering is the last core process, where the rest of the organic material is extracted, incinerated. The powdered metals are heated to almost near melting point. The powdered metals fuse, they consolidate and shrink, and you end up with a solid metal part.
Okay.
So to elaborate on the operations, compounding being the first operation is where we form the material, or it creates a feedstock of which we're going to put into the injection molds and mold. It primarily consists of two main components. We have the raw powder component, which is going to be your alloy. The metal injection molding industry, it has a lot of flexibility when it comes to materials and alloys. So it might be a stainless steel, it might be a low alloy steel, it could even be an aerospace grade or titanium material.
Yeah.
So that's the raw powder agent. And then the second area is the binder. The binder essentially exists just to be able to flow the material in the injection molding process. Right. So binders vary throughout the industry, and Jason will touch base on the catalytic debind process and the two different binder systems, primary binder systems that go through that process. But at the end of the day, metal injection molding feedstock consists of that raw powder and that binder agent. It's compounded into a feedstock that can be fed into the hoppers in preparation for the injection molding process.
Okay.
The injection molding process is very similar to that of polymer injection molding, which a lot of our customer base is familiar with. So at the end of the day, that feedstock is loaded into a hopper. And that material is injected at high temperature as well as velocity into what can be complex injection mold tooling.
Yep.
That is where the actual forming of the component takes place. It's then ejected from that mold and prepared for the next operation.
Right.
So once the part is molded, it needs to go through a debinding operation, and there's a couple of different feedstock systems that are commonly used in the industry. But in either scenario, there's a two-part binder that's mixed with the powdered metals. So in debinding, what happens is the parts are either loaded into large tanks and submerged in solvent, or they're loaded into ovens and a nitric acid vapor is applied to the parts. And the first component of the binder system, whether it's either a wax or whether it's a polymer, is either dissolved or catalytically dissolved out of the part, and that part of the component is wicked out of the compact. And what you're left with is, on a microscopic level, you're left with a network of interconnected porosity. And what that does is two things. So after debind, you have a little bit of polymer left to hold the powdered metals together.
Right.
And then secondarily, you have this network of porosity, which allows the polymers to escape the part during sintering. If the part is not properly debound, then you will have what we call blowouts in sintering, where the material couldn't escape.
Right.
So after after debinding, the parts are go into sintering. There's a number of different sintering furnaces that are used. There's continuous furnaces, vacuum furnaces. There's box furnaces that are done in standard atmospheric pressure with process gases.
Right.
But basically all three of them, the remaining organic materials are extracted and ultimately incinerated. The temperatures are raised to just below the melting point of the material of the alloys.
Yep.
The powdered metals start to consolidate. The part isotropically shrinks roughly 20%, and you end up with a solid metal part. And that is, basically
That's the basic process. And then there are some finishing operations we're going to talk about later. What would you say, generally speaking, at Alpha Precision Group, we do multiple sintering operations or have multiple styles? What are the kind we have?
We employ mostly vacuum furnaces here.
Okay.
And we do also have one box furnace that uses atmospheric pressure and hydrogen and nitrogen process gases. But we're typically a vacuum furnace house here.
Okay. And then I guess what would as far as the difference between a continuous furnace versus a vacuum furnace, which is a batch operation, is that more based on economics, or is that based on performance of the product, why you use either?
It's actually it's a couple items. So in a continuous furnace, it is very specific to alloy, and because we actually employ so many different alloys and so many different feedstocks, it's advantageous to have a batch process where we don't necessarily need to be pushing all the same material through a sintering run at any given time.
Right. Okay. Well, gentlemen, thank you for your insight. We appreciate you watching our video here. If you have a project that you think would work for the MIM technology, or you would like to do an educational event, that's something we offer our customers, we'd be happy to come on site and give you a more in-depth training on the technology, since we're just kind of touching the surface here. So if that's something you're interested in, you can contact us by going to our NicholsPortlandInc.com website or alphaprecisionpm.com website. And if you go to the website and contact us, we'll get in touch with you right away. So we're hoping to hear from you soon.